Hello, welcome to 13 Universal, and we are going to continue with A-level CI biology. This is Shedro. So we are looking at immunity series 2. Immunity series 2. Get to the writing part. Let's solve some questions. Let's crack some questions. So let's go to the first question here. Yes, solve it with me, okay? Some children are born with severe combined immune deficiency. That's key. These children do not normally have any T lymphocytes and suffer from many diseases. They don't have T lymphocytes. How may these children be cured? How do we help them? They don't have T lymphocytes. They were born that way. So what are you going to do? Pause the video. What is the answer? Okay. A says bone marrow transplantation. Yes. Bone marrow contains stem cell for blood cells. So that will help. Okay. It's a continuous use of antibiotics. No, you don't use antibiotics to treat this disease. Of course, because not all infectious diseases are bacteria or caused by bacteria. Okay, so this doesn't work. Transfusion of antibodies, that's not the best either. Vaccination against all diseases. Some of them mutate. When they mutate and change the antigen, this may not work. Okay, so transfusion of antibodies may not work because some of them will cause the trigger immune responses, and this can work. So this is the best way. Bone marrow contains stem cell for blood cells, so they will differentiate and produce T lymphocytes. Okay, so the answer is A. All right, so let's go to number 2 quickly. To prevent a disease, dead bacteria, please don't put living bacteria into someone, it's dangerous. Okay, may be injected into the body. What type of immune response is produced? If you're injecting bacteria into the body, bacteria has antigen, so this is not natural, this is deliberate, it's artificial. So no, not natural. So C and D eliminated. We're on A and B. Let's go. Now it's going to be active because bacteria has the antigens will trigger immune response, and then memory cells will be produced. Okay, so it's going to be active because immune response will be triggered or elicited, and of course memory cells will be formed. So it's B. Okay, yep. All right, now look at this. It says the graph shows the primary and secondary responses of the immune system to antigens. Okay, that's the graph. Pause the video and look at it. So what are responses X and Y? Okay, now if you look at X, can you see that concentration of antibodies is very high? Okay, it didn't take time. Weeks after first or second exposure, so there was rapid production of antibody and the quantity is very high. This is for secondary. Okay, immune response. Secondary immune response, number 1 is very rapid. Number 2, large quantity of immune response, large concentration of antibody is usually produced. Okay, this must be secondary. Now this must be primary because it takes time, right? Because of clonal selection takes time. All right, before the specific clone of lymphocytes or B lymphocyte that can recognize the antigen. So this is going to be X, must be secondary immune response. Okay, so B and D, sorry, A and B eliminated. So now Y is primary. Okay, let's select this. Secondary immune response caused by so guys, watch this. Yep, so now we have been able to eliminate that. It cannot be. X is secondary immune response. Y, it is rapid and we have higher concentration of antibodies, so it can't be A or B. So of course Y is primary. Why? Because it is not rapid. It takes time for clonal selection to occur. So secondary response, look at this. This is a secondary response caused by cloning of B lymphocyte formed during primary response. Okay, yeah, this is secondary response caused by cloning of T lymphocyte. Now T lymphocyte does not produce antibodies, it's only B lymphocyte, so that's what we're going to consider C. Okay, of course Y is primary immune response. Okay, so X is the answer. So let's go to the next question. You say a child is vaccinated against a viral disease a few weeks later, she's exposed to the same virus. What is expected? What is expected response to this exposure? So what is expected? Okay, once it's exposed to this virus, it is increased number of B lymphocytes. Okay, yeah, it's gonna happen. Increased number of T lymphocytes, that will happen. But what are we expecting to happen? Large numbers of antibodies are released. Yes, this is it. This is what we're expecting. Now, antigens are on the virus, but this is so that while we vaccinate is to provide immunity. Immunity means, okay, where the disease is not able to spread, okay, due to the fact that large antibodies are produced by the body, and then it prevents them from spreading, it destroys them. So this is where the antibody, the immunity lies. Okay, all of this should lead to this. Okay, so C is what is expected to happen. All right, that's what is expected to happen. All right, let's go to the next one. Which statement describes a role of lymphocytes in the immune response? Lymphocytes. So lymphocytes. So pause the video and try it. Lymphocyte. B lymphocyte divides to produce killer. No, they don't produce killer lymphocyte. It's T lymphocyte produce killer. B lymphocyte produce memory cells. Of course, they should be able to produce memory cells. But which role? The memory cells are also produced by T lymphocytes, not just B lymphocyte. Okay. Now, T lymphocytes are involved in the humoral. Now, humoral immune response involves the synthesis and production of antibodies. T lymphocytes do not produce antibodies. All right. This is a T lymphocyte clone producing antibody secreting cell. It doesn't. So it looks. Which one do you think is most? This is actually wrong. Okay, this is wrong. Okay, this is wrong. Shouldn't the answer be what? Shouldn't it be B? Yeah, B. Now, number 6 says, which development in vaccine production would be most important in the fight to eradicate measles in developing countries? So in developing countries usually are less economically developed nations. So they have financial issues, economic issues, okay? Sometimes they're fighting wars and all of that. Yeah, a combined vaccine to combat it and other disease. When you use a combined vaccine, they may not be able to produce combined vaccine, and this may cause serious side effects, and these developing countries may not be able to handle it. A is not the best option. B is a single vaccine without a need for boosters. Yes, this a single vaccine that can do the job, right? So we don't need to vaccinate them, because vaccination programs in developing countries, they are very, very difficult and challenging. So we just need one single vaccine that we don't need to give them booster doses again. We don't need to vaccinate again. That one that works. B sounds like the answer. C says vaccine containing only one live. Now, live measles are dangerous. They could cause the infection. All right, so don't try this. This is a vaccine produced by genetically engineering technique. These countries, but they may not be able to sponsor this. Okay, they may not have the money for genetic engineering. This is expensive. So B is the most important suitable option there. All right. Yeah, it says a graft of tissue such as skin from a different person usually rejected by the body. Which statement about graft injection is correct? Now I'm going to list the options. What do you think is the answer? All right. So the graft is rejected by the B lymphocyte because they make and release antibodies which react to the surface antigen on the graft cells. Well, this may happen, but if you are talking about the graft, let's look down more. Now B says the graft is rejected by the lymphocyte B lymphocyte because T lymphocytes are not stimulated to produce. No, that's not the reason. Okay. Now C says the graft is rejected by T lymphocyte because the graft tissue caused T lymphocyte to release. T lymphocyte do not release antibody. This is already wrong. Now D says the graft is rejected by T lymphocyte because they circulate in the body and then gather the graft. Now they gather there. Okay. Yes, that is it. So they stimulate immune response. They circulate there and gather there. Do you understand? Because this is going to take a long time for it to happen, of course, if these antigens are non-self, okay? But this is going to happen as soon as possible. All right, so this is the, all right, and of course it cannot be C because C do not release antibody. This is wrong. This is a typo. All right, is the okay. So which statement about B lymphocyte is correct? So which statement about B lymphocyte is correct? Okay. Which statement? I want you to pause the video, okay, and tell me what is the answer. All right. Just pause the video. So work on it. Work on it. So now let's look at it. Which statement about both B lymphocytes is correct? You can see that. Now B lymphocyte, okay. They become active only when a specific antibody binds to their surface. No, they become active when a specific antigen binds to them, not antibody. So when antigen on pathogen binds to them, that's clonal selection, so that they get them activated. Right, so this is not correct. B says they divide to form clones when meeting an antitoxin in a cell. No, it's when they come into contact with an antitoxin. It's not when the antitoxin is inside the cell. Right. C says they produce memory cells to respond to antigens when exposed in the future. Yes. Okay. So they produce memory cells. Okay. And that memory cells, when they encounter the same antigen, they will divide quickly and produce antibodies. All right. And that gives the organism immunity. Now this says they release hormone-like cytokines. They don't release cytokines. What releases cytokines is T helper cells, not B lymphocyte. Okay. So what do you think is the answer? Of course, C. All right, come with me. The photomicrograph shows human blood with 3 types of white blood cells, white cells labeled. All right, I want you to pause the video and then which row correctly identifies these white cells. These are white cells. Now, guys, watch. You see, this T has compact nucleus. These 10 parts, 10, they are all nuclei. So how you differentiate them? You look at the shape of the nucleus first. All right, the one that has compact nucleus is usually lymphocyte. So T is a lymphocyte. Check where there's T lymphocyte. Okay, A has lymphocyte as T and D has lymphocyte as T. Okay, so we eliminate B and C instantly. So let's check again. Now the one that has lobed nucleus is neutrophil. This is kidney or bean-shaped nucleus. This is macrophage. Okay, R is macrophage, S is neutrophil. However, 2 of them are phagocyte. So which option shows S and R to be phagocyte? Is D. Okay, so you can pause the video or just go over it again if you don't understand. All right, so 10 says, what are the functions of T lymphocyte during an immune response? T lymphocyte destroy infected body cells. Okay, let's go. So what's the answer? Okay, once it destroys infected body cells, yes. What can do? T killer cells can destroy infected body cells. Differentiate into memory cells, yes. T lymphocyte, they form memory cells to retain the track record of the pathogen, so that in future invasion of the body by the same anti-pathogen, they can ward it off. Okay, so secret antibodies, no. Antibodies for B lymphocyte, not for T lymphocyte. So it's 1 and 2. Okay, so thank you for watching this video. Please follow us on YouTube. Make sure you subscribe, make sure you share, make sure you comment. So our next video will be on series 3 of immunity. Thank you. I'm Shedro. Bye.